Hello, my name is Karla Salazar, and I have been studying at the University of Texas Rio Grande Valley, also known as UTRGV. For this project, I worked with my advisor, Dr. Waylin, and our set of collaborators shown in the screen. The project that I will be presenting today is the impacts and in-depth study of the environmental contaminant PFOS and its interactions with water. To start off, I want to share that this project revolves around the toxic and persistent environmental contaminant perfluoroctanoisophonic acid, also known as PFOS. This contaminant has been widely used previously by manufacturing companies to produce different products such as firefighting foam, pesticides, floor polishes, and shampoo since the 1950s. Due to the wide previous production is that this environmental contaminant inevitably escaped into the environment. It has now been found to be bioaccumulated into the soil, air, and water systems. More alarmingly, it has also been found to be bioaccumulated into the animals and human blood worldwide. This project aligns with the United Nations Sustainable Development Goals in three categories. These would be the good health and well-being category, the clean water and sanitation category, and the life below water category. I also want to add that there are two phases to this project. The first phase is about a survey being done in southern China for environmental contaminants. For this phase, we're working to establish a baseline for environmental contaminants with the inclusion of PFOS in southern China. The second phase for this project is to study a prototype molecule of PFOS, which is fluorosulfonic acid, in order to see the energies and structures as it interacts with the water. This information will help analytical chemists to extract it from the water and the environment in the future. Before I get into the actual research work, I would like to present the impacts of this environmental contaminant. To start off with the social impacts, this environmental contaminant has been found worldwide in human blood. Figure 1 shows a world map representing the light color areas, which are the least affected areas, and the dark color areas, which are the most affected areas. As it can be seen, the United States is one of the most affected areas. This means that there is a higher concentration of PFOS in the blood in the United States generally. Figure 2 shows all the potential health complications when relating to this environmental contaminant in the human system. Some examples, it would be that it would disrupt the liver, the nervous system, and the immune system. Figure 3 shows the PFOS percentage into the dietary intakes. No matter at what life stage we're at, we get by accumulation of PFOS since a very early age. The environmental impacts are very straightforward. This environmental contaminant is bioaccumulated into the environment. That includes the air, water, land, and life systems. As long as this contaminant is still into the earth, biological systems will get affected, such as animals and humans. Currently, this contaminant is not well known. Therefore, PFOS can come costly. Figure 5 shows the economics from the corporate point of view. These two companies lost around hundreds of millions of dollars in lawsuit money for the persistent use of PFOS. Figure 6 shows the testing cost for PFOS. The cost can increase up to $800 just to know how much it is being found into your system. Figure 7 shows the annual disease that it costs the United States annually. It is in the billions of dollars. Now, after discussing the impacts, I would like to get into the actual research. For the methodology, there are two sections to it since there were two phases to this research. The first phase, which is about a survey done in the water systems of Puchen, China, involves several equipment used. However, for the detection of PFOS, the main piece of equipment used was the ultra-high performance liquid chromatography tandem mass spectroscopy. For phase 2, the main piece of equipment used was the program Gaussian 16 that was used through the cluster computers from the Texas Advanced Computing Center located in Austin, Texas. For the results for phase 1, it was reported that for PFOS there was no detection. However, there was a total of 23 contaminated sites out of the 57 locations. The chemicals being exceeded by the national standards in at least one of the sites for seawater and groundwater include the chemical oxygen demand, inorganic nitrogen, inorganic phosphorus, and ammonia nitrogen. Figures 7 and 8 show the location of where the survey took place, and tables 1 and 2 summarize the contaminated locations for groundwater and seawater. For phase 2, results showed the simulations for the most stable structure of behavior as fluorosulfonic acid dissociates. Figures 9 through 12 show how fluorosulfonic acid is being detached by the water molecules. In conclusion, this research is done to bring an awareness to the general public about the toxic and environmental contaminant PFOS. Within this project, we want to create a baseline in southern China due to the limited testing in that region and to conduct energetic and structure simulations to predict the behavior of the molecule as it interacts with the water. I want to conclude by saying that this research is not done. We will be working on conducting a survey here locally in the valley and to conduct experimental work with fluorosulfonic acid to prove the behavior and to be able to remove it from the environment and the water in the future. I would like to thank and acknowledge the Walsh Foundation, Dr. Parwinder Graywell, and the Graduate College from my university. I would also like to thank and acknowledge the Office for Sustainability for Financial Help and the NCSE conference for giving me an opportunity to present my work. This concludes my presentation, and I thank you for your time.